Alrighty, so let's go for the third question today. We are going to go ahead and start to solve this one. Points A and B lie on the circumference of a circle of radius r centimeter with center at 0. The sector A or B, first of all, I'm going to note that this is a sector. I'm given a sector. Is shown on the following diagram. The angle A or B is denoted as theta and is measured in radians. This is very important, so the measurement is in radians. The perimeter of the circle is 10 centimeters, and the area of the sector is 6.25 centimeters square. Show that for A, r squared minus 20r plus 25 is equal to 0. So, what am I given here? For this question, given, I'm going to start doing this so it helps. I'm given 1, a sector. 2, what about this sector? What do I know about this sector? I'm given the angle theta in radians. So, the angle theta is in radian. Angle in radians. Then another thing that I'm given is the perimeter of this sector. So this sector with r and this arc length here, I'm given its perimeter. I'm gonna go ahead and take note of that. I'm given the perimeter, which I'm gonna say P is equal to 10 centimeters squared. Actually, I'm just going to write the full thing so it helps. Perimeter is equal to 10 centimeters. And additionally, I'm given the area of this sector. Area is equal to 6.25 centimeters squared. And for question A, I'm just asked to prove something. I'm just asked to prove that 4r squared minus 20 plus 20r plus 25 is equal to 0. Okay. The first thing I need to note here, after all of what I'm given, in order for me to figure out the answer, what the question is really asking me, or how to approach this, I need to figure out that in this equation, I'm only given r, which is our radius. So now, from here, I be just trying to be tricky by telling you, hey, this answer is going to be easy, but you just got to figure out what I'm asking for. So the first thing is, okay, what does the perimeter mean? A perimeter of a sector, what does it mean? It means that I have this side here, let's call it this side here, and then this side here, and then this side here. The perimeter is just imagining somebody walking all over this whole shape. So what would that be? It will be r, the first one, plus another r, and this arc length here. But hey, I don't know what this arc length is, but I know something. I know that I can find the arc length given a certain formula, right? So that's what I'm going to be doing. I'm going to be going over here on my IB formula booklets and try to find where the arc length of a sector is given. So I don't know exactly where it is, so I'm just going to be starting down all over here, prior learning, and I will go down, continue going down, nothing on this side, keep on going, and I will come across something. I'm just going to look because I know it exists somewhere here. There you go, right? This is standard level. Another length of an arc, so aka arc length, can be obtained, sorry about that, by taking the radius, measured in radians. This is very important because they gave us the radius, the angle, the angle is measured in radians, sorry. And then the radius is in any units. So the angle is in radians, which matches our requirements, and then the radius is in centimeters in our case. So the arc length is going to be r times theta. I'm gonna go back here. So I can rewrite this perimeter as my radius. So I have my first side, which is the first r, plus the second r, the second side, plus, now, what is the arc length? The arc length, we say it was r theta, right? Because it was arc length was given as r times theta. So I get r plus r, which gives me 2r, and then plus r theta. That is going to be my perimeter. And what is this perimeter equal to? It is equal to 10. So I have my first equation. Fine. Second, we're asked to find the area. We're told that the area of this sector is 6.25. Similarly, I want to figure out what does this actually mean? What is the actual area of the sector? How did IB come up with this answer? Okay, I'm gonna go back again on my book and try to figure out, hey, the area of a sector is given by half r squared theta, where once again, theta is measured in radians. This is very important because if it was measured in degrees, we will have to do the conversion before we actually use this formula. So, I am told that the area of a sector is half r squared theta. Fine. I know that r is my radius. Here it's just r. So I'm going to have to write 1/2 r squared theta. This is equal to 6. I literally just repeated what I just wrote. 6.25 centimeters squared. Fine. Now, something happens here. When I look at those two equations, I notice that both of them have theta and r. Theta and r. But my first question asked me to write this equation, which is a quadratic equation, because I have r squared as my leading coefficient, as my leading term, sorry. Now, what I'm going to be doing here, I'm going to be strategic. I notice that both equations here have theta and r, but this last one only has r. So I'm going to try to figure out a way, maybe, to write this whole thing in terms of r. And the way I can do it is, if I have two variables, I have r and theta, I'm going to write this whole thing as if I'm looking for theta. And you'll see why in a bit. If I do that, I will end up with 2r plus r theta. Actually, I'm going to come down here for simplicity. I'm going to put this one in a box because that's what I'm looking for. So my first equation is 2r plus r theta is equal to 10. I'm going to write it as if I'm solving for theta. So I'm going to subtract both sides first by 2r. So I'm going to end up with r theta is equal to 10 minus 2r. And then I'm going to be solving for theta. That would be theta. That will be dividing both sides by r. So I'm going to end up with theta is equal to 10 minus 2r over r. You can continue and just divide and split this one into 2, but I'm going to keep it like this for now. And my second equation was half r squared theta is equal to 6.25. Once again, I'm going to be writing it in terms of theta. So I'm going to multiply both sides by 2 to get rid of that to get rid of the 1/2 on the other side. So I'm going to end up with r squared theta is equal to 6.25 times 2 gives me 12.50. 12.5. And then from here, r squared, I'm going to divide both sides by r. I'm going to divide both sides by r squared. So I end up with theta is equal to 12.5 over r squared. Okay, so this is the beautiful part again I was talking about. The reason why we did this is because now we have two equations that relates r to theta. And not only that, but we have two equations for theta. So we can find theta using this one or the other one. Which means that if theta is equal to 10 minus 2r over r, and theta is also equal to 12.5 divided by r squared, that means that both of them are actually just equal to each other. They are the same. So I can actually literally do what I just said, make them equal to each other. So I end up with 10 minus 2r over r is equal to 12.50 over r squared. Perfect. And now I can just rearrange this equation to make sure that I end up with what I'm being asked for. And the reason why I'm doing this is because I'm trying to get this into a quadratic equation, this quadratic equation here, where the right side is 0 and the left side is equal to this beautiful quadratic equation. So essentially, I'm going to try to make this side here equal to 0. And the way I'm going to do it is first, multiply both sides by r squared. So if I multiply both sides by r squared, I have 10 minus 2r over r times r squared to get rid of the denominator on the other side. So I end up with 12 times 12.5. When I multiply this, I get rid of 1r here. So I end up with 10 minus 2r times r, which gives me 10r minus 2r squared is equal to 12.50. And remember, we want this side to be equal to 0, so we're going to subtract 12.5 on this side, from both sides. So 10, so I end up with 10r minus 2r squared minus 12.5 is equal to 0. Wait, normally we should be done, but IB tricked us. If you look at this equation, what we're looking for, our coefficient here, the leading term of our, the leading coefficient of our, the coefficient of our leading term is actually 4. It is not 2. So what we're going to be doing is I'm going to be tricky. I'm going to change this. I'm going to change what I have here and multiply it by -2. And the reason I'm doing -2 is because first, this one is -2. And I want this -2 to be turned into a 4. So this whole equation can be multiplied by -2 in order for me to get that 4. Because I have a decimal, but IB didn't give me a decimal. So let's try to do that. If I multiply this whole thing by -2, I end up with -20r plus 4r squared plus 12.5 times 2, that is equal to 25. This still is equal to 0 because anything multiplied by 0 gives us 0. And I can rearrange it in terms of the leading coefficient, instead of the leading term, the leading exponent if you want. So this will become 4r squared minus 20r plus 25 is equal to 0. And that is exactly what IB wanted us to find. So that's for question A. Now, for question B, they said, hence or otherwise find the value of r and the value of theta. Fine. We have this quadratic equation here that we just found, and this is equal to theta. Remember? So this is basically theta because we did theta is equal to theta itself, and then we found this. And the way now we can find what's the value of r here is obviously, because it's a quadratic equation, we're going to factor it out. So 4r squared minus 20r plus 25 is equal to 0. Let's try to factor that out. How do you factor this out? How do you factor this out? Okay, so I'm going to factor 20, negative 20, into two things. So negative 20, I can do, what can I do here? I can factor it into negative 10 r, actually negative 10, no, actually negative 10 r minus 10 r plus 25. Yes, I can factor it, I can split it into two, so I end up with 4r squared minus 10r, and then negative 10r plus 25. Here I'm gonna factor out 2r, so I'm left with 2r minus, this is gonna be 5. And then I can do the same thing here, where I'm gonna factor actually 5. So I'm gonna be left, actually I'm gonna take negative 5, I'm gonna factor negative 5 on this side, negative 5. If I take negative 5, I end up with 2r, once again, minus 5. So my factor here is, as you can see, 2r times 2r. So essentially, 2r squared. 2r minus 5 squared, sorry. So 2r minus 5 squared, this is actually equal to 0. Remember, because this whole thing was equal to 0, I just forgot to put it down there. I can now solve for r. So I have 2r minus 5 is equal to 0, because if I take the square root of 0, it's still 0. So 2r is equal to 5, because I add 5 on both sides to get rid of negative 5. This gives me that r is equal to 5 over 2. Perfect. Now, with this, I know what r is, but I'm also asked to find what theta is. And I remember that theta is the same as either this one or this one. So you choose. You can plug in the value of r in either one or the other, and you find the answer. And I personally like the first one on top here better, because it doesn't involve decimals. But you can choose whichever you want, and then it will still give you the same answer. So here I'm going to be using theta is equal to 10 minus 2r over, over r. Now I'm going to put back what r is, so I'm going to have 10 times 2 times 5 over 2 over, what is r? R is 5 over 2. Sorry, my 5 is actually ugly. Here, this one we cancel, so I end up with 10 minus 5 over, keep, change, flip, actually. Actually, I'm just going to do it step by step. Over 5 over 2. The rest will be 5 over 5 over 2. And if I do the keep, change, flip, I'm going to keep the one on top. And I'm going to change the side to a multiplication. And I'm going to flip the bottom one. So it's going to be 2 times 5. So my theta is actually equal to 2 radians. And that is how you find it. And that is your answer. So for this question, as you will notice, IB has just been tricky. They already knew what you were going to find, and they already knew how to help you get there, but they did not want to tell you exactly, hey, we actually just want you to find the theta using the area and the perimeter. So what you have to do here is to reason based on definitions. That's kind of like how we do things in mathematics, where we base our understanding on definitions. What does it mean to have the perimeter? What does it mean to be a sector? What does it mean to have an area? And also, how did I find the solution that the solution that they just gave us, right? Because most of the time it's just that. It's just going back to the definition of what is it, the area of a sector, and then being like, oh, the area of a sector is 1/2 r squared theta, and already gave us the area. Similarly, the perimeter, I need to remember that perimeter is side plus side plus side plus side, whatever. How many sides you have to add them together. And then, because in my answer here, I only have r, I'm just going to focus on, okay, if I both my equation that I just found, the area and the perimeter, both have r and theta, but my final answer is only asking me for theta, so that means that I'm going to focus on theta. I'm going to write the whole equation in terms of theta. So because I have two variables, so I'm going to make theta equals to something r. So I would have two equations that relate r and theta, and equate them to each other, and then I will get what I'm looking for. All right. Thank you so much for watching. Please don't forget to like, subscribe, and press that notification button so that you don't miss any of my videos again. I will keep on updating and posting more as time goes. Thank you so much for watching.